let's talk about GDPR, and not in a point of maybe finding some loopholes or some way to dealing with it. Because GDPR is actually about privacy, about accountability and responsibility. And that's something good. That's something that we should uphold. That's something that we should respect. So let's look at these things. Let's look at privacy by design and how can we apply it? How can we, instead of trying to fight our ways to weasel through, be the best kid in the class? So first of all, I think the most important rule of putting privacy-sensitive data on the blockchain is don't do it. Don't put privacy-sensitive data on the blockchain. So I could actually end the talk here, but that would be really short. So it's really bad, no matter if you have a public blockchain or if you have a consortium chain. If you have a public blockchain and you're making some kind of distributed application, you're knowingly asking your users to go and distribute the data to the world. You cannot guarantee that it's only going to be used for the purpose that you intend to. Others can actually go analyze it, do whatever they want with that data. Sure, you can argue that there is no controller, but it's you creating that program that is asking the users to do this, knowingly that the data can be abused. So if you have a consortium blockchain, you have similar problems, because this blockchain is going to live on forever. Anybody who's going to join the consortium is going to get a copy of that data. You don't know in advance how that's going to be, who those people are going to be. Are they going to have the best interest at heart with that data? Maybe you have, but maybe those who enter in the future don't. So basically, don't do it. So the most common thing that you hear is, well, you know, we can just encrypt the data. So if we encrypt the data and we do that uniquely, then we can simply delete the encryption keys, you know, and that's pretty much the same, you know. The keys are gone, so the data is not accessible anymore. That's the same kind of thing, right? Well, not really. So why? Well, first of all, it's clearly not allowed. When creating these rules, they explicitly said that the data needs to be erased, and they did it for a purpose. One of them is really, I like, you can find it on Stack Exchange. You know, if you look at the history of cryptography, every algorithm is broken eventually. You cannot guarantee that because it's not broken today, that's going to be safe forever. And reason two, it's pretty pointless. So if you have the encrypted data, it's mostly not available within smart contracts. So we've heard about some encryption techniques, homomorphic encryption, etc., where it might be possible, but at large, it's not available there. So if you use a general key pair, so you say, okay, I know the public key of the other party, and I'm going to encrypt it with that so they can decrypt it with a private key, then it's impossible for them to target this specific data and go and delete it. They can delete their private key in general, maybe, but that would delete also other data. So that's not practical. So really, if you do create a unique key for this specific data, then that key now needs to be distributed to the parties that needs to access the data. But if you're doing that, and if you're building that infrastructure, then why don't you just distribute the data itself? So that's really the point. Like, why do we want to put this data on the blockchain in the first place? So what we heard a lot is it's immutable. You know, it's on the blockchain, it's immutable. Well, it's not really immutable. I mean, the copy on my machine, I can just change. You know, it's just bits and bytes. the point what makes it kind of immutable is that A, it's distributed, so everybody has it, but that's not something really you want with private data because of these problems. A second thing is that it's tamper-proof. If I have this data, if it's on the chain, and if I do tamper with it, it's very clear. I mean, I cannot recreate all these signatures of the following blocks. So that's really what we're looking for. We're looking for data that's tamper resistant. So what can we do? Well, making something tamper resistant, that's pretty simple. I mean, we can take the data, create a hash of that, and put that hash on the chain. So this is a little bit naive. That's not the right way. I saw some people taking pictures. Because if I have the hash of that data, I can still, if I have the same data, if I know your name, I know your phone number, I know the format, I can still create the same hash and find that on the blockchain. So I can see, hey, you were there and this is the action that was taken. So what we actually want to do is we want to create an envelope. We want to take that data and make sure that the only thing we can actually do with the hash is verify that the data is there and the data is real. So we take the data, we take a timestamp, we take some random data, we put it all in an envelope and create a hash of that. So if you have that, unless you have that actual copy of the data, so you will distribute a copy of the data, there's no way for you to recreate that hash and to do anything with that. So rather than just taking the hash, which can be used for looking up, we've made sure that it can only be used for verification. And now, another important part, of course, of the blockchain is distribution. Because we want to distribute that data to the parties that should have it. Well, really, here also, we are looking at not distributing to everybody. We really want the person that wants to process the data to actually do a data request. Because then we can say, hey, we know who has the data, and we know why he wants it and how he's going to use that. So you can, of course, you can do that manually, but we're looking at smart contracts, and what we have actually are live contracts, but at least we're looking at automation. So what we want to do is we want to create the rules, create all the instructions at forehand. So you know at forehand what is going to happen, what data might be collected, who might process that. So you create a contract for that, where you have both the on-chain instructions, but also the off-chain instructions. And what we actually do with that is, rather than saying, hey, now we have this contract and we put it on a global blockchain, we create a miniature private blockchain, ad hoc blockchain, specifically for this one contract. So again, if that contract is on there and all that data gets on there, it might still be identifiable. But if we do it like this, so we create a new layer, we can now say, okay, this copy, actually a copy of everything that's happening, is only shared with the participants. And it's anonymized. Or not anonymized, it's, no, I forgot the word, but you only know the role. So you know the client asked this, the processor asked that, the controller asked that, the lawyer asked that. So all the roles are identified rather than identifying the individuals. And all those transactions, they get anchored on the public blockchain, because we don't want to go back to the consortium chain. We do actually want to have a public network. So this is an interesting kind of dynamic that we have here, where we have a permissionless system. Anybody can start up a node, but what they're actually getting are only hashes. They can only use that to verify the data. They're not getting anything of substance. And the only way to get some real data you can use is by being a participant of this process. So you're getting a private, permissionless system. And then even on that layer, so even on the layer of the participant, there's not any privacy sensitive data, because that's something that you have to request. So at some certain point, you want to do a specific action where you need that data. That's known in advance, so even if that data was actually generated earlier, your node, the node that's there for the user, can just hold it. So you're creating that controller. And it's only passed to the processor when the processor actually needs that. And when he's done, he can also just go and delete that data. Because if he needs it again, he knows where it is, and he knows to which system it needs to ask it. So it's really the dynamic that we're looking at. We're doing requests every time that we want that data, and we're logging that. So rather than thinking about, okay, how can we find these loopholes, we're actually thinking about privacy and how we can protect it. So that data doesn't need to be stored on all the systems all the time. No, we actually created a system where we can request that on demand. So that's really the important part. We think about data protection by design. We only have the data that we need right there at that moment. So we're creating the processor. The controller is actually there for the user holding that data. The processor is there to process the data and then remove it. And we're keeping records of all the activities. That's in that system ourselves. We don't need to think about creating a secondary system, but that's just part of our solution. And most of all, when we need to actually erase everything, we can. We can erase the linked data, and we can even erase the ad hoc chain, removing all records of everything that's happened. The only thing that's left are hashes with no further meaning if the data is erased. So really, this is another way of thinking that. Not how can we find the loopholes to try to work with blockchain and make it GDPR compliant, but really, how can we use the techniques that we know from blockchain to really boost the privacy and make it a better place? Thank you.